Close your eyes and imagine a world unlike anything we know today. A world where the vast Atlantic Ocean does not exist, where you could walk from what is now New York to Morocco without ever setting foot on a boat. This was Earth, not as we see it now, but as it was over 300 million years ago, a time when all the continents we recognize today were fused together into a single, colossal landmass known as Pangaea. Pangaea, a name derived from the Greek words pan, meaning all, and gaea, meaning earth, was not just a theoretical construct, but a living, breathing supercontinent. Stretching from pole to pole, it was surrounded by a single, enormous ocean called Panthalassa. The sheer scale of this ancient world is almost impossible to comprehend. Picture the Himalayas, the Andes, and the Rockies all part of a single, unbroken chain of mountains, with rivers flowing across landscapes that would one day be split by thousands of miles of ocean. But how did we come to know about this lost world? The story of Pangaea is not just a tale of ancient geology, it's a detective story, one that spans centuries and involves some of the most brilliant minds in scientific history. Enter Alfred Wegener, a German meteorologist and geophysicist whose curiosity would change our understanding of the planet forever. It was the early 20th century, a time when the idea that continents could move was considered sheer fantasy. Yet, as Wegener pored over maps in his study, he noticed something that seemed too striking to be a coincidence. The eastern coastline of South America and the western coastline of Africa appeared to fit together like pieces of a giant jigsaw puzzle. Wegener was not the first to observe this. Others before him had remarked on the curious alignment of the continents. But Wegener was the first to take the idea seriously and to gather evidence to support it. He scoured libraries and museums, collecting data on fossils, rock formations, and ancient climates. What he found was nothing short of revolutionary. For instance, he discovered the fossils of an ancient reptile called Mesosaurus in both Brazil and South Africa. How could the same creature have lived in two places separated by an ocean, unless those places had once been connected? He also found matching layers of rock in the Appalachian Mountains of North America and the Caledonian Mountains of Europe, suggesting they had once been part of the same mountain range. Yet, when Wegener presented his theory of continental drift in 1912, the scientific community was skeptical, to say the least. The prevailing belief was that Earth's crust was static, unchanging. Wegener's theory might have faded into obscurity were it not for the relentless march of scientific discovery. Decades after his death, new technologies began to uncover the mechanisms that Wegener had only suspected. In the 1950s and 60s, scientists mapping the ocean floor discovered something extraordinary, a vast, underwater mountain range known as the Mid-Atlantic Ridge. This ridge was not just a geological curiosity. It was a place where new crust was being formed, pushing the continents apart. Further evidence came from the study of Earth's magnetic field. Rocks on the ocean floor recorded a history of magnetic reversals, creating symmetrical patterns on either side of the Mid-Atlantic Ridge. This was the smoking gun, proof that the seafloor was spreading and the continents were indeed moving. Today, we know that Pangaea was just one chapter in Earth's dynamic history. The continents have been in constant motion for billions of years, driven by the forces of plate tectonics. Wegener's theory, once ridiculed, is now the foundation of modern geology. And yet, the story of Pangaea is more than just a scientific triumph. It's a reminder that our planet is alive, always changing, always evolving. The idea of a supercontinent has captured the imagination of people around the world. From documentaries to blockbuster films, Pangaea has become a symbol of Earth's ancient past. It's a reminder that the world we live in today is just a snapshot in a much larger story. A story that began billions of years ago and will continue long after we're gone. But Pangaea is more than just a relic of the past. It's a key to understanding our future. The same forces that broke apart Pangaea are still at work today, shaping the planet in ways we can only begin to imagine. Who knows? Millions of years from now, the continents may come together again, forming a new supercontinent, perhaps one that future scientists will call Pangaea Proxima. Until then, the story of Pangaea remains one of the most fascinating chapters in Earth's long and storied history. In the heart of the Indonesian archipelago, nestled between the islands of Java and Sumatra, lay a small but mighty volcanic island known as Krakatoa. To the locals, it was a place of both beauty and dread, a sleeping giant whose occasional rumblings reminded them of its hidden power. By the summer of 1883, Krakatoa had been quiet for over 2 centuries, its lush slopes covered in dense tropical forests and its shores lapped by the warm waters of the Sunda Strait. Few could have imagined that this peaceful paradise was about to become the epicenter of one of the most catastrophic natural disasters in recorded history. The island itself was a complex of 3 volcanic peaks, Purbawatan, Danan, and Rakata, the largest and most active of the 3. For months leading up to the eruption, small tremors and steam vents hinted at the turmoil brewing deep beneath the surface. Fishermen reported strange phenomena, water temperatures rising, fish behaving erratically, and the air filled with the acrid scent of sulfur. Yet, no one could have predicted the scale of the devastation that was to come. Krakatoa was not just a volcano, it was a ticking time bomb, and the world was about to witness its explosive fury. By May 1883, the first signs of unrest became impossible to ignore. A series of small explosions sent plumes of ash and steam into the sky, coating the surrounding islands in a fine, gray dust. The eruptions grew more frequent and violent throughout the summer, with thunderous booms echoing across the Sunda Strait. Ships passing through the area reported ash falling like snow, turning day into night. The Dutch colonial authorities, who controlled the region at the time, grew increasingly alarmed. Yet, without modern monitoring equipment, they could do little more than watch and wait. On August 25th, the volcano entered a new, terrifying phase. A series of massive explosions shattered the island, sending shockwaves rippling through the Earth's crust. The eruptions grew so intense that they were heard over 1,600 miles away in Perth, Australia. Ash and pumice rained down on villages, burying homes and crops. The sea around Krakatoa began to churn violently, as if sensing the impending disaster. But the worst was yet to come. Deep beneath the island, a chamber of molten rock, pressurized to the breaking point, was about to unleash its fury on the world. At 10:02 a.m. on August 27, 1883, Krakatoa detonated with a force that would leave the world in awe and in mourning. The explosion was so powerful that it was heard as far away as Rodriguez Island, nearly 3,000 miles to the west. The sound traveled around the globe 4 times, a testament to the sheer energy released in that single, catastrophic moment. The shockwave from the blast shattered windows and shook buildings across the Indian Ocean. The eruption itself was a nightmare of fire and fury. A column of ash and gas shot over 50 miles into the sky, darkening the heavens and plunging the surrounding region into total darkness. Pyroclastic flows, superheated clouds of gas, ash, and rock, raced down the slopes of the volcano at speeds of over 100 miles per hour, incinerating everything in their path. The island of Krakatoa, once a towering volcanic peak, was literally blown apart, collapsing into the empty magma chamber below. But the devastation didn't end there. The collapse of the volcano triggered a series of monstrous tsunamis, some reaching heights of over 100 feet. These walls of water slammed into the coasts of Java and Sumatra, wiping entire villages off the map in an instant. Over 36,000 people lost their lives that day, their stories swallowed by the sea and the ash. The world had never seen anything like it, and it never would again. The effects of Krakatoa's eruption were felt far beyond the shores of Indonesia. The ash and sulfur dioxide ejected into the atmosphere spread around the globe, creating a veil that blocked sunlight and cooled the planet. For years after the eruption, global temperatures dropped, and weather patterns were disrupted. Farmers around the world struggled with failed crops and unusual weather, unaware that a volcano on the other side of the planet was to blame. The eruption also gave rise to some of the most breathtaking sunsets ever recorded. The ash particles in the atmosphere scattered sunlight in unusual ways, painting the skies in vivid hues of red, orange, and purple. Artists around the world, including the Norwegian painter Edvard Munch, were inspired by these eerie, otherworldly skies. Munch's famous painting The Scream is believed to have been influenced by the blood-red sunsets caused by Krakatoa's ash. Scientifically, The eruption marked a turning point in our understanding of volcanoes. It was the first time that a volcanic event had been documented with such precision, thanks to the global network of telegraph lines that allowed news of the disaster to spread quickly. The eruption of Krakatoa became a wake-up call, forcing scientists to recognize the immense power of volcanic activity and the need to study it more closely. Today, the name Krakatoa is synonymous with destruction, but also with resilience. In 1927, a new island, called Anak Krakatau or Child of Krakatoa, emerged from the caldera left behind by the 1883 eruption. This new volcanic peak has been growing ever since, a reminder that the forces that destroyed the original Krakatoa are still at work. Anak Krakatau is closely monitored by scientists who study its activity to better understand the behavior of volcanoes. In 2018, a partial collapse of the island triggered another deadly tsunami, proving that the legacy of Krakatoa is far from over. Yet, despite its destructive potential, the island is also a haven for life. Plants and animals have slowly returned, reclaiming the land in a testament to nature's ability to heal. The story of Krakatoa is more than just a tale of destruction. It's a story of the Earth's raw power, of the fragility of human life in the face of nature's fury, and of the enduring curiosity that drives us to understand the world we live in. As we look to the future, Krakatoa stands as a warning and a wonder, a reminder that our planet is alive and that its story is still being written.